All right, guys, so I wanted to take a moment to do a small refresher on one-step equations before we push into those two steps. Okay, so I'm going to take a look here at this first equation. This first one says negative 2x is equal to 10. Okay, so reminders, anytime I have a number and a letter sitting next to each other within an equation, there is an invisible multiplication sign. Okay, so what I see here is something times a negative 2 is equal to 10. Okay, so I'm going to ignore the negative sign for a moment because I know for some of us that's our struggle area. Okay, and I want you to think, what number times 2 will give me 10? Okay, so kind of thinking backwards. If I'm thinking what number times 2 gives me 10, I can also think fact family. 10 divided by 2 will give me that missing number. Okay, so I know this number right here should be 5. Okay, but now I have to come back and bring that negative in. Okay, so we remember kind of some rules that we learned back in 6th grade. That when I am doing multiplication and division, that in order to get that positive 10, I need a negative times a negative to give me that positive 10. Okay, so that tells me that this missing number right here should be a negative 5. Okay, because 5 times 2 will give me 10, and then a negative times a negative will give me that positive 10. Okay, so that's just kind of thinking mathematically. I know a lot of you can go in there and kind of plug and chug, but I want to talk now about the actual math process that we use when we start to get into some harder equations. Okay, so I know a lot of us right now can mentally think about what number times 2 gives me 10. But when I have like 4 or 5 steps, it gets a little bit more challenging to think about what number should go in that missing spot. Okay, so we use what is called inverse operations, and I talked about that a little bit ago when we talked about fact families. Okay, but essentially, what I'm trying to do is figure out what this missing number is, right? And so then I undo whatever is happening to it, and we undo by using inverse operations or opposite operations. Okay, so again, this right here says times a negative 2. Okay, so what I'm going to do is I'm going to divide by a negative 2. Okay, a negative 2 over a negative 2. Think about a fraction that has the same number on top and bottom. That equals 1. And 1 times x is just x. So now we have the x by itself. Okay, but if I divide this side by a negative 2, I need to also divide this side by a negative 2. And so 10 divided by 2 is 5. And then again, thinking about that rules that you learned in 6th grade, okay, I need this to be a negative 5. Okay, so this would be the proper steps that we show using that inverse operation. Okay, now I'm going to show you a strategy, and you can find anything that you want to use at home, okay, to help you with this. Okay, but if I come in here and I take a look at this equation, I'm going to cover this up. This says something below this piece of paper, something plus 5 is equal to 15. Okay. Now I know a lot of you already know in your head what that answer is, but let's go ahead and work through the appropriate mathematics. Okay, so again, our equal sign is our balance beam. And if I want to know what is under here, I have to undo what is happening to it. So I have this blue box and 5 is being added to it. So the opposite of adding 5 would be to subtract 5. Okay, and that will give me 0. So you'll remember hearing me say a lot, 0 pairs. Okay, but again, as always, if I am equal, if I am balanced, in order to maintain that balance, if I subtract 5 from this side, I also need to subtract 5 from this side. So now all I have left on this side is my blue box. I'm going to say my blue box is equal to 15 minus 5 gives me 10. Okay, now under this blue box was my x, so I know that that x is equal to 10. Okay, so now I want to apply this coming into our two-step equations. Okay, so coming back to here, all we had to do was undo that multiplication by dividing, and here we had to undo that addition by subtracting. Okay, well in this problem, I have multiplying and subtracting. This says 9 times x minus 10 equals 8. Okay, so a strategy that I like to use is to take this two-step equation and turn it into two one-step equations. Okay, that makes sense. One step plus one step gives me two steps. Okay, so if you remember back when we learned this, I talked about identifying your variable. Okay, well, my variable's right here. So take a look. I'm going to take my blue box. And again, you can use whatever you want that you can find at home. And I'm going to cover up my variable. So just like when I covered up the x on this equation, here I see something minus 10 is equal to 8. Okay, so something minus 10 is equal to 8. Let me go ahead and start with my inverse operations. If something minus 10 is equal to 8, then 8 plus 10 will give me this value, right? So I'm going to go ahead and I'm going to do the opposite of what I see here. Minus 10, the opposite is going to be plus 10. Okay, and if I'm at negative 10 and I add 10 again, guys, that's going to give me 0 and cancels it out. But again, to maintain my equality, if I add 10 over here, I need to add 10 over here as well. Okay, so now I know whatever's in this blue box is going to be equal to 8 plus 10, which is 18. Okay, so now I'm going to move my blue box. Ooh, okay, so I'm going to bring this down. This says 9 times some number is going to equal 18. And again, I know a lot of you right now already know on the top of your head what that answer is, but now let's go back to the appropriate mathematics. Okay, this says 9 times x. So I need to undo that multiplication, and we undo multiplication with division. So 9 divided by 9 gives me 1, and 1 times x is just x. Okay, but if I divide this side by 9, I need to also divide this side by 9. 18 divided by 9 gives me that x is equal to 2. Okay. All right, let me go ahead and move this problem because we're running out of space here. Okay. But this is something that I see a lot of us struggling with. So let me go ahead and write this problem down, giving us a little bit more room. Okay. So majority of the time, your variable is in that first term of the equation. Okay, but every now and then we see equations that look like this one, and this is where we start to struggle a little bit. Okay, so again, if you remember when we first learned about solving equations, I talked about finding your variable. So I'm going to go place my blue box. My blue box is a little big. Let's see if I can make it a little bit smaller. Okay. Okay. So when I cover up this variable, okay, and I can look at it like this, or I can cover all of this as well. I personally like this. Okay, so I see 8 and something else is equal to a negative 12. Okay, so some of us struggle a little bit when it comes to this, but let's just go ahead and envision that we're adding. 8 plus something else is going to give me a negative 12. Okay, I can also look at it like this and say 8 minus something will get me to a negative 12. Okay, so I know a lot of us really struggle with those integer rules, so you might want to visualize this problem. Okay, I am at a positive 8. Can't see my number line. Okay, and I am wanting to get down to a negative 12. Okay, so think about how many degrees do I have to lose to get from 8 degrees down to negative 12 degrees? Okay, well, I'll have to move 8 spaces down just to get to 0, right? So I'll have to go 1, 2, 3, 4, 5, 6, 7, 8, and that'll get me to the 0. And then to get from 0 to 12, negative 12, I'll have to go down 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Okay, so I want to think about how far did I move all together? Well, if I moved 8 spaces here to get down to the 0, and then I have to move 12 spaces to get down to negative 12, all together, we took a drop of 20 degrees, right? Okay, so when I look at this equation again, I see 8 minus something is going to give me a negative 12. Okay, well, I know this something now should be 20. Okay, so this is another strategy I like to use. 8 minus, and now we figured out the something should be 20, is equal to a negative 12. So now I'm going to come and ignore the rest of the problem and just look at the blue box and what I said that blue box should be equal to. Well, I said that blue box should be equal to 20. So when I look at this, I see some number times x should give me that 20. So what should our x value be? Okay, so when I think about it like this, then I know our x value should be 10. Now, let's go ahead and, because it was kind of confusing here, I want to take this thought process now. I'm going to substitute that 10 in and show you where we're getting this from. Okay, so this is a way that you can check your own answer. So I'm saying that that x value should be 10. So I'm going to replace the x with a 10 or substitute with 10. Okay, thinking of order of operations, we do, please excuse my multiplication first. So I'm going to have 8 minus 2 times 10 is 20 is equal to a negative 12. Okay, and then 8 minus 20, if I'm at 8 degrees and I drop 20 degrees, I'm now at negative 12. So I get negative 12 is equal to negative 12. Okay, and that is a true equal statement. So we found the right answer for x. Okay, now some of you are probably like, well, what happened to all that inverse operation stuff? Okay, so I want to make sure I show that piece as well. Okay, so I'm going to come down here now and I'm going to show how we do inverse operations on an equation like this. Okay, if inverse operations is your go-to. Okay, so ask yourself what's happening to the x. Well, the x is being multiplied times a negative 2. And then I see this positive 8 over here. And this is generally where we tend to struggle with those inverse operations. This 8 is positive. Okay, so if I bring back my blue box, okay, I need this positive 8 to go away. And the way we get that to go away is by pairing it with its opposite or inverse operation. So a positive 8 and a negative 8 is what's going to make that cancel out. Okay, remember, always, 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 whatever you do to one side, you need to do to both. Okay, so now I have whatever's in this blue box should be equal to whatever negative 12 minus 8 is. Okay, so if I need to come back to that number line, negative 12 minus 8, coming down 8 more, that's going to get me to that negative 20. Okay, so now bring my blue box back. And my blue box said negative 2 times some number is going to give me a negative 20. Okay, well, if I see times a negative 2, the opposite of that would be to divide by a negative 2. And I get 1 times x is x. What I do to one side, I need to do to both. Okay, and we get a negative 20 divided by a negative 2. So a negative divided by a negative gives me a positive 10. Okay, so right there, guys, I just showed you 3 different ways to get that positive 10.